Hi, welcome. Hi, welcome to today's episode of your math class thing, lesson 86. We're going to actually tackle this in two parts, and today is part one. We're going to be translating sine and cosine functions. Translating doesn't mean that we're going to turn it into Spanish or something. It means we're going to take a picture of a sine or cosine function, one of those wibble wobbles, and we're going to move it, the whole thing, left to right, up and down. That's it. Up, down, left, right. That's what we're going to do. Or up, left, right, down, whichever. Now it looks like I'm dancing like a white guy. Yeah. So there we are. What we need, what you probably need to have in your calculator is, I guess maybe we'll start with sine functions, is to clear out your y equals thing and put in, oh golly, like sine, and then the parentheses, like, I guess just sine x. How about that? End parentheses. And what we're going to do is we're going to add some things into the equation in a couple of different places to make our equation go left or right or up or down. And zoom trig, zoom 7 on this guy. Okay. And I'm currently in degrees, but I'm going to be drawing up on the board in radians. So, you got your sine x. That's it. Our normal standard, stupid, boring sine x. Right? Something like that funky thing right there. Again, all I'm going to do is I'm going to take this one cycle, I'm going to move it left and right, or I'm going to move it up and down. Now, how do I do that? Where do I do that in my equation? Let's do f of x, okay? F of x equals cosine x. I'm going to write the form for you today. X minus h plus k. I'm going to write it like that to make it kind of look similar to parabolas. Okay? Now, I write it like that so that you are, at least, we'll take and just make an analogy, I guess is what I want to say here. That the HK used to be like the center, right? Or the vertex, I guess you should say, of a parabola. Now we're talking about just H is going to regulate the left and the right movement of the whole picture, and K is going to regulate the up and down part of it. Okay, so we got H and K. Now also remember how with parabolas the form was the same thing here. X was always x minus something. So if this says x minus 2 in there, that means I'm going to go 2 to the right. And if it says x minus negative 2 or x plus 2, that's going to move us to the left. Out here, usually you start off with it over here and you have like y minus k, but then it gets moved over here so we can graph. And plus k tells us exactly what we want to do. If you said plus k, we're going to go up. If it's minus k, we're going to go down. So let me write that here as well. This would look like x minus h to go this way, and it'll look like x plus h to go that way. Right? I'm going to kind of let that sit there for a minute. So our basic function here is, oh snap, this one's sine. I should have written sine in there. Sine starts at 0, and cosine starts high. 1 for our amplitude, and then since we didn't put any number right there, this has a period high. Who's high? Equals to high. Oh, it's Dutch again, everybody. Wave to Dutch. You can't see Dutch, but there's Dutch. Okay, I think I was saying something like period of a normal sine or cosine function is 2 pi. So today we're not gonna mess with the period, which means we're not gonna put any numbers right there. We're not gonna change this from 1. We know how to manipulate the amplitude. That's actually pretty easy. We're only going to fiddle with a number in here and a number out there. So we're only going to make our picture go left, right, up, and down. That's all that we're worried about. So this is kind of our basic scheme here. I'm gonna even simplify this, and we'll just do one of those movements at a time. Okay. Translate. By the way, translations. Again, shifting the whole picture up, down, left, or right maintains both the amplitude and the period of a sinusoidal function. The shape stays exactly the same. We're just picking it up and sliding it. The whole thing. It doesn't get longer. It doesn't get shorter. It doesn't get stretched out this way. Those types of dilations are going to happen when we do it. I don't even get to that stuff this year, but we could throw it all together and stretch it and move it and flip it and bop it and twist it. Okay, all that stuff. So I'm gonna simplify this down even more and just start with this. It's as if this is saying x minus 0. Okay, and so we're gonna ignore that. Saying we're not moving it at all left and right. We're only gonna think about moving it up or down. Okay, so you try it. You just plug in. You got your sine x, and then you go and you plug in some sine x plus stuff and some sine x minus stuff, and you'll see pretty quickly what goes on. Okay, this goes up k units, and then if we had sine of x minus k, then we're talking about going down k units. Very easy to check, right? You forget what happens there. You can type it in and see what happens on your graph. Okay, so let's go ahead and do this. And then I'm going to graph that. And I guess I need to put this to go up to 2, right? Because I'm going to take my whole picture, I'm going to add 1 to every single point. It means this is going to start right here rather than right here. And it's going to go up to here rather than right here. And it's going to come down to here rather than right there. And then it's going to, let's see, it's going to hit this as its lowest point. And it's going to come back up to here rather than here. Everything gets shifted up 1 unit. Okay? So then I just kind of connect the dots. We get the exact same shape. Just go with me here. Everything got shifted up 1 place. That's a vertical translation or a vertical shift. Okay? A vertical shift or translation. Moving. Again, the period stays the same, so the period is still 2 pi. The amplitude is still the same. From its midpoint here of 1, it only goes up 1 to 2, and it goes down 1 to 0, so that stays the same. We've only manipulated it going up or down. Okay? So again, play around with that a little bit. Move it wherever you want to. You can make pretty patterns with it. Make waves. The amplitude and the period stay the same. Every point just moves up or down k units. All right, clear the board. Let's go left and right. Now I've got cosine here. Cosine starts high at 1, gets to the top of the circle, bottom of the circle, or to the left side of the circle, whatever, unit circle, bottom of the unit circle, and then back to where we started from. 1 full cycle, amplitude of 1, period of 2 pi. This is kind of like if we start off this time, we're going to want to have a parent function, f1, or y1. Maybe let's do it that way. Do it the way your calculator would do it. y1 equals cosine x. Okay, kind of have that in the background, and then we'll fiddle with things a bit. If we would like to move it to the right, we're going to go, let's just pick a number. Let's pick, well, let's do this in radians. Let's do it so that it kind of stays in its pattern. Let's go minus pi over 2. Use your little fraction bar. Or you can go maybe y3, and this time we'll go x plus pi over 2. So you get the same shift left and right. Now you tell me which one moves it left and which one moves it to the right. Okay. No, it's not getting frustrating yet. Okay, so if you do those, let's take y2, and maybe I'll do y2 in red. X minus the phase shift. That's what this one's called. It's called a phase shift. Horizontal or phase shift. Then it's going to shift every point pi over 2 radians to the right. Okay? Shift to the right. So instead of this point being here, it's going to be here. Shift it pi over 2 radians. Take this point here, I'm going to shift it pi over 2 radians. I take this point, I'm going to shift it pi over 2 radians. I take this point, shift it pi over 2, and this point I'll shift it pi over 2. It'll end up at 5 pi over 2 radians. So to do that, I guess I got to back it up. Where would point that gets shifted over here, right? This thing would go like this at negative pi over 2, and this point gets shifted pi over 2 radians this way. So connecting the dots, we got here, 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 back up there, right? Everything's been shifted that way, pi over 2 radians. Again, we're going to call this one, rather than a vertical shift, this one is called phase. Phase. Now, we could actually shift cosine so that it's on to sine. In fact, we actually just did that. My new red curve there is the sine curve, which means that this equals sine x. This will be later on in trigonometry, pre-calc, that'll be one of our trigonometric identities. Okay, that cosine lags behind sine or vice versa by pi over 2 or 90 degrees. So we want to get them in phase. We're going to shift it 90 degrees or pi over 2 radians over. So phase shift or horizontal. But this is the preferred terminology. And then in consequence, if we're going to have this one, everything's going to shift that way. Maybe I'll do that in blue. Shift this way pi over 2. My original here shifts this way. This point shifts to here. This point shifts to here. Pi over 2. This one shifts to here. And this point shifts to here. So what we'll get is and then I guess this one would shift. I have another one here would shift there. Okay, so now I've taken the black one, I moved it this way, pi over 2 radians. That again, aka phase shift. And so combined those translating, I'll get either sine or cosine. We'll have the minus h plus k. So I can actually move it up and left or down and right or down and left or up and right. I can do any of those that I want to. I'm going to give you some to graph, and before you hit graph, I want you to predict what's going to happen. Hang on. Here's my basic like standard starting place. This is like my parent function, cosine x. I just put some placeholders there, minus 0, plus 0. And then we got 4 different combos here, up, down, or left or right. And what I want you to do is copy these down, make a prediction. Is it going to go left 1, right 1, up 1, down 1? Those are your 4 choices. write these down, predict where it's going to go, and then graph them and see if you got it right. Should be straightforward enough that you can do that. All we're doing is going up, down, left, or right. In our next episode, we'll tackle what's called the standard form, where we'll be able to change the amplitude. We'll change the period. We're going to do horizontal shifts or phase shifts, and we're going to do vertical shifts. We're going to put them all four things together in one equation that's called the standard form for these sinusoidal curves, for the translations and scale changes. So that's our next episode. We'll combine this with what we did previously with manipulating the frequency or the period and the amplitude of sines and cosines.